Alright, so let's look at this problem together. We're given two vectors in R3 and are looking for a unit vector that is orthogonal to U and V. Okay. So we know how to find a vector that is orthogonal to U and V, right? How do we find that vector? We can find that vector through doing the cross product. So the cross product U and V will give us a vector that is orthogonal to factor U and factor V. But this vector, it may not be a unit vector. Recall what is a unit vector? It is a vector of length 1. Okay, so next we want to adjust the length of this vector. Alright, so suppose, how do we find a unit vector? Suppose I have a vector that's called W. If the length of W is equal to 5, how do I find a vector in the same direction but of length 1? I can just divide the vector W by 5, right? Because if now I look at the length of this new vector, this is 1/5 of the length of W. And how much is the length W? It's a 5. So I will have 1/5 times 5, that is a 1. So in general, whatever vector you have, if you want to keep the same direction but adjust the length, so then it has length 1, then you do the vector divided by its own length. So this new vector you have has length 1 and it has the same direction as W. So that's how you're gonna do number 2. So number 2, the step 2 is you will find the length of the vector you get from step 1, from the cross product, and use that to adjust the vector U cross V. Okay, so keep in mind here it is a scalar, here U cross V, it is a vector. So I'm using scalar multiplication to adjust the vector, the length of the vector, so then it has length 1. This is the plan. Okay. Now I want you to pause this video and try to solve the step 1 and step 2 by yourself. And hit continue when you're done. Okay. Once again, the key point is you do not rush. You do step by step. Be patient. Patience is the key. Now go ahead, let us find U cross V. So U cross V, alright, there we go. There's a formula, ijk always goes to the top row, whatever the first vector goes to the second row, whatever in the second vector goes to the bottom row. Take the determinant. Okay. So I look at diagonal direction, the I has 1 times 2, so let me just write 2. The J has, oops, this should be 2, 1, 3, right? So I should copy the components I have into here, and let's double check minus 1. 1 minus 1, 2, okay, so we're good. For the J, we have 3 and then 1, so 3 times 1, that is a 3. And for the K, it goes here, so I have 2 times negative 1, so that's negative 2. Alright. The off-diagonal direction. Let's go from here, K, 1, 1, so minus 1. Whenever it's off that direction, I have minus sign. And then J2, and it goes here, that's another 2. So 2 times 2, that's 4. Minus 4. Then the last one is I, and goes here, so minus 1, minus 3. So that's negative 3, but with minus sign, okay? Because it's off diagonal direction. So what I have is, in the I component, I have 2 minus negative 3, that's 5. 3 minus 4, that's negative 1. Minus 2 minus 1, that's minus 3. This is a vector that is orthogonal to both U and V. Why? Because that's the geometric property of the cross product. But we're not done yet, because what this problem wants is a unit vector, so we have to adjust the length. Let's find the length of a U cross V. Remember, the formula of the length of a vector is square root of the sum of each component squared. So that's 5 squared plus minus 1 squared plus minus 3 squared. Summing all together, I get square root of 35. The length of this vector is root 35. So a unit vector, or let's say so I have the unit vector that is perpendicular to or orthogonal to both U and V is 1 over root 5 times 5 minus 1 minus 3. Okay, so you can leave your answer like this, or if you feel like distributing the scalar into the components, we're more than welcome to do so. So minus 1 over root 35 minus 3 over root 35. Remember, this is how we do scalar multiplication. So either form is fine. It's your personal choice. The key here is understanding the cross product will give you a vector that is orthogonal to the given vector U and V, the vectors you use in the cross product. And if you divide any vector by its length, then the vector you get is a vector of length 1. So that is so-called a unit vector. Okay?